All right, welcome to the coding session with respect to the Reuters dataset. This is still the introduction to deep learning. And the reason why we're gonna do this coding exercise is twofold. Yeah? First of all, we only had one reference point during the logistic regression. And secondly, it would be great to have a baseline. Yeah. So let's see how a dense deep learning network compares to a logistic regression. Reuters is also a standard data set in Keras. So with a bit of luck, we're going to be able to reuse a bunch of the code. So let me start by going to my drive and try to find the IMDb exercise. Let's see here. We have Intro to Deep Learning IMDb. Let's make a copy of that one. And then open the file. There will be no drive to mount as the dataset comes with Keras. So the only thing we're gonna do immediately is change the title, and this will be Reuters. All right, so IMDb delete. So let's run the first code. We're connecting, but I saw something is wrong here. So IMDb we need to replace by Reuters, and let's run it again. Vocabulary, no change. We take the 7,500 most frequently used words. Here we have this bug fix, which we solve with this block of code and run it. Here we just print a list of sequences, not different from the IMDb case. Now we're gonna vectorize. And let's take a look at this code here. So here we can change because the way we're going to vectorize the labels is not gonna be like this, because here our labels are vectors with 46 rows. We need to have a different way of vectorizing these labels. And luckily, Keras provides us with the tools to do this in an easy way. So we're gonna import two categorical and call one hot train labels and one hot test labels, applying this function on the train and the test labels. So with this, we have vectorized and the training data and the test data. Next one is the importation of necessary libraries and the buildup of the model. Yes, it's all gonna be dense layers, but not 16. It's gonna be 64 units here. Activation will not be sigmoid because we have 46 classes. It will be a softmax. And here we have 46. Yeah. We have 46 units. So let's run it. Here we go, no problem. Then we're gonna set aside a validation set. We're only gonna take the first 1,000 elements. So let's take a 0 out of these 10,000. Yeah. Partial X-train, this is all fine. But why validate is Y train, yeah, and Y train now is called one hot train labels. We copy this one and we paste it here. Here we go. And here partial Y train is also one hot train labels. So let's run this. It works. Then model compile. Let me see here. Yes, we need to change binary cross entropy to categorical entropy because it's a multi-class problem. Here we go. Partial X train, partial Y train. This should all work. So let's run it 20 epochs. So here for the writers, we see that the validation loss is minimal for 10 epochs. So if we run the network for 10 epochs, the result is actually 79%. So basically it's the same as with logistic regression. So let's take note of that, 79% for a simple dense neural network on the Reuters dataset. All right, welcome to the results session on our first coding exercise related to a simple dense neural network. For the Reuters multi-class classification problem, now remember we had 3 layers here and a softmax. The score was actually the same as we had with logistic regression. So no improvement here on the 79%. And 79% is not that great. You know? It's actually a bad classifier.